Hello guys, welcome to Knowledge Pond YouTube channel. This is the third part of MVC 6 video series. In the video 1 and video 2, like part 1 and part 2, we have seen what exactly the Microsoft .NET 2015 and what are the technologies comes under this .NET 2015. And apart from that, we have seen .NET Framework, full-fledged .NET Framework 4.6 and their features. And we have also seen the tiny .NET frameworks, like the small .NET framework like .NET Core and native frameworks. And we have also seen .NET execution model. Once we write the code, how dynamic compilers Roslyn comes into the picture, how it compiles our .NET code for different targeted platforms. And we have also seen the Microsoft Web Stack evolution from 1996 to till today, how web is evaluated from the Microsoft world. And we have also seen the current challenges which we are facing in the world of web when we competing with the modern hardware. And we have also seen that ASP.NET 5 and MVC6, ASP.NET 5 advantages, ASP.NET 5 architecture, how the MVC6 and ASP.NET 5 fit in the world of open source and cross-platform, and why the Microsoft renamed MVC6 and ASP.NET 5 to ASP.NET Core 1.0. And apart from these major things, we have also seen that client-side and server-side supported frameworks, client-side and server-side supported dependency management tool, and we have also seen the basic concepts of MVC and the current MVC challenges and MVC6 architecture, MVC6 benefits, and for MVC6, our availability of project templates and project structure in the solution. Uh, like files, MVC files, and folder structure. In this session, we'll go through like what exactly the open source and cross-platform, how the MVC6 like MVC6 ASP.NET 5 they redesigned from the core level to support in the world of open source and cross-platform. And what are the challenges in current web server architecture, like our favorite IIS architecture? And then we'll go through that OWIN open web interface for .NET, how it resolved the current web architecture challenges, and OWIN implemented frameworks, and what exactly the Katana architecture, and the Katana components, logical layers, and then we'll see the middleware. So what are the current challenges in the current web server in the IIS? So if you see that web world started from Microsoft around 1996 to till today, around it is 20 years almost. So in the year of 22, like 2002, Microsoft started .NET framework. Then they decided my current web world, like in that time the ASP was their web technology. They wanted to integrate that ASP to .NET framework. Then Microsoft started to support a web world with the .NET, and this added ASP or ASP is added part of .NET framework that we called as ASP.NET. Then the idea was to provide the unified development for both the desktop and web clients as well and services as well. And the ASP.NET, the framework offered a lot of plenty server-side controls libraries to develop rich web user interface. And moreover, this ASP.NET Runtime provides the core functionality through the server-side events and server-side controls. So then what is the problem? So far it is working well. Then what are the challenges? So if you see this diagram very clearly, on the top of web server we are installing the .NET framework. On the top of the .NET framework we are installing the ASP.NET Runtime. On the top of that we are deploying our ASP.NET apps. And internally, ASP.NET uses system.webdll and web-related interaction, and it provides a rich set of functionality to develop complete web application, whether it is web pages or web API services, or it is ASP.NET MVC applications. In some cases, really, if you see, we are not really completely using the ASP.NET core libraries, server-side supported things for even if you develop a small kind of applications like We are not using complete functionality of system.web, though it refers to the whole assembly to load it server memory. In that case, like if you are developing a small application, and we really don't need a complete system.web DLL feature. So this makes unnecessary usage of resources. Because of that one, it completely bound to IIS due to this heavy dependency on the system.web DLL or assembly. So in general, if you see the IIS is very fast web server, if you deploy any like HTML kind of web pages, the response request and response time is very fast. And if you install our ASP.NET runtime like system.dll, then the whole process is taking so much of time for processing our request and response back to the user. That means the current ASP.NET runtime is heavyweight, and to process single request also it is taking longer time. So system.web exists even ever since from ASP, and it contains many things internally that we know we are not even need to use complete application. So it consumes complete resources, making our application in general very slow. That means for processing single request, single even even to render a single web page from the ASP.NET application, it takes it loads complete ASP.NET runtime into the memory and executes even our single requests, so that it takes a lot of system memory, system resources. This really makes so much of burden for web server as well. So because of this tight coupling, like there is a full dependency between a web server and ASP.NET runtime. This makes a lot of time to execute our single request. And in some cases, suppose there is small bug fixes in the ASP.NET runtime, and you need to completely reinstall the ASP.NET runtime. So in that case, we need to provide a maintenance window to the user. So we are doing some maintenance in this project, and once you replace this fix in the ASP.NET runtime, then we need to intimate the users that there are little like challenges in the current web server. Then we'll see how like Microsoft resolved by using the new web server technologies. If you see this diagram, and when we request any resource from the web server, the request it first goes to web server, from that it goes to ASP.NET runtime. Once it executes our like request, the response again back to the web server, from web server to response. That means there is a tight coupling between the web server and ASP.NET runtime. So in market, and moreover, there is another challenge is when we competing with modern hardware, modern software. The current ASP.NET application itself is a lot of problems. Even that web server also is some. There is little challenges are there. And now if you see in the market, the web world has changed a lot and lot in many areas, like for designing and development perspective or responsive perspective. And the modern web application are required right now, all the web applications required very lightweight and modular, and need to support modern hardware. In the terms of asynchronous calls, it needs some asynchronous way to execute our request, and it has to support a variety of data format and variety of lightweight protocols. And this coupling between the web server and ASP.NET is little resolved in the MVC, world of MVC. They made partial DLLs, partial libraries, which we can get it on the fly from the Nugget. But still there is a problem if you still using the ASP.NET applications and ASP.NET runtime. So to compete the modern world, like modern web world, Microsoft also started by introducing OWIN and Katana architectures in the world of ASP.NET to decouple the web server from the runtime. So we'll see how the Microsoft implemented this OWIN and Katana architecture. So OWIN is Open Web Interface for the .NET. And if you see this architecture, in the earlier slide we have seen the web server, the request first it goes to web server, from the web server it goes to ASP.NET in the previous versions of ASP.NET. The Microsoft, to resolve this issue, Microsoft introduced a new interface between the web server and ASP.NET runtime, which we call as the OWIN interface, like a open web interface for the .NET. So OWIN is not a framework, and it is a body of a specification and rules, and it is a completely theory, like it is complete specification to design any kind of interface. And it describes how the web development framework such as ASP.NET MVC or ASP.NET web pages should interact with the web servers. It is a specification how web servers and web application are to decouple from one another. It gives us the interaction between the HTTP servers and applications. It also defines the standard interface. It provides the standard interface between our runtime and web server. It does not have any tools and libraries, anything. It is just a setup body of specification. The main goal, the main design behind OWIN interface is to decouple web server from the runtime environment and our applications. So one way we can say that it is essentially collection of best practices which we have proven in the web development community. So there are other development areas from the web. They are still using OWIN and they succeeded in many areas, and they have seen that there are success stories testimonial in that by using OWIN architecture in their implementation. So this OWIN shows us to implement our web applications which are very open to extensibility. The moreover, by using OWIN, our applications can be extended. So as each web developer should constantly be on cutting edge new technologies. And this is one way to say that as suppose we are the web developer, we want to be up to date for the new technologies. So if you are developing and designing apps from using ASP.NET runtime, so this is definitely is not up to date development. That means there are other web development apps are using OWIN architecture. They means they're completely decoupled their apps from the web server, and they are able to support a multi operating system. So if we like our Microsoft also supported the same architecture in the world of ASP.NET, then we are also up to date when we compete with other web application developments. And if we learn completely the OWIN, so we are completely compete with uh, different web development tools. So due to this OWIN implementation, we could reduce our server running cost, and our web servers tight right now or not depends on any web server. So Windows servers are more expensive. If you say like if you develop our web application and if it targets our web application for multi operating system, and there should be some lightweight definitely if you compare to Windows. Our Windows servers are very costly and like it more expensive than Unix based ones. If you deploy our web application on the Linux or OS X Mac OS, the maintenance cost and the responsive and moreover the hardware consumption also is very less. So if we support this OWIN architecture, definitely we can decouple our web applications from our web server IaaS. So there are some OWIN implemented architectures are there in the market, and there are like Katana, server side and host side. They implemented Katana, OWIN, and SOVI, and frameworks like Jasper, Nancy, Signal, or Web API, WebSphere, ACSP.NET. The implementations are like Katana, Freya, and ASP.NET 5 and MVC 6. That means these are the frameworks already being used this Wovena into their application development. So what exactly the Katana? The Katana is the Microsoft implementation of this OWIN specification. That means OWIN is a specification, Katana is implementation from Microsoft. So Katana is a set of open source OWIN components built by the Microsoft. At the main, it is used to build a web-based web application. Now onwards, we can design and develop a web-based web application. It is fully developer framework made to make a bridge between the current ASP.NET frameworks and OWIN specification. The OWIN is a specification. One way you can say Katana is a .NET library. As I told you earlier, the OWIN there is no tools for OWIN libraries, but Katana there is a tool and there is a library where the library which we can make use of in our .NET applications. So we can get it that Katana from Nugget. So what are the main benefits? Like if you use Katana in our applications, what benefits will get it? The one is the portability, modularity, flexibility, lightweight, performance, scalability, and decouple. More are the main benefits that decouple from the web server. So what other advantage like a portability level? Portability means our components are substituted easily to for new components once it is ready and become available. That means if there are any changes on any one of the components, we can without complete replacing the system, we can update dynamically, and this gives us our third-party frameworks can seamlessly run on Microsoft server. At the same time, Microsoft frameworks also can potentially run on third-party servers and host as well. So modularity, in the respect of modularity, how it advantages in Katana components are very small and more focused. So it gives us full control over the application developer to determine the components which we can use to our application. That means we have like a composable set of middleware we can stick in the request pipeline. That means we have complete command over whole application, how the request should process before reaches to web server. So lightweight, like there is a less hardware consumption, so it consumes very few resources, so that it is moreover the portability lightweight. So Katana architecture, the broadly divided into like four logical layers and components. The very first layer is application, middleware, server, and host. So let me start with the first layer is the application. The application layer is responsible for our client application, generally ASP.NET MVC, ASP.NET MVC web pages, and it could also be like Windows application, even sometimes console application. And these are the application mainly concentrated by the users. They're really not bothering about what special about when and all those things. But this layer is common still. Right now we are using that one in current applications as well. The next major layer or component of Katana is the middleware. This is the main, there is a major changes in the architecture is the middleware. The middlewares are small application components that can be incorporated into HTTP request pipeline to handle the requests and responses. Each component can choose whether to pass the request to the next component in the pipeline, and can perform the certain actions before and after the next component in the pipeline. ASP.NET 5 has taken a lot of inspiration for this middleware architecture from other web frameworks like Ruby, Node.js, and even OWIN. So that means here is the middleware is completely customized, composable pipeline. Suppose if our middleware contains any ASP, if it is using any MVC or a web API signal or identity or any authentication, any custom pages, those everything we can compose, we can configure, we can set the priority, and we can set as well as what component should execute first, and how it can give the responsibility for the next component. So everything is a customizable. We can configure, we can set up our middleware so that it can execute before our request reaches to a server. If you say the request, once we requested web pages, it goes to the first middleware. Then once as soon as the first middleware completes its complete roles and responsibility, then it passes the control to the next middleware. And as soon as the middleware 2 is completed his responsibility, then it passes to middleware 3, then it passes to the server. So the middleware layer is composable of set of components and can be larger frameworks sometimes. The supported frameworks is MVC6 and Web API, ASP.NET Identity and Signaler. And there are some non-functionality middleware components like authentication, authorization, caching, error pages, static pages, browser links. So these cross-cutting components are generally registered towards the beginning of the pipeline so that it will be process the request for all the frameworks and component register later in the pipeline is good. That means if you register the composable, as I told you, middleware is a composable component set of component. So the first priority to set this authentication, authorization, caching, error pages and browser links. Then you can use MVC6 and Web API, ASP.NET Identity and Signaler. There is no like a proper rule to set follow the particular order, but you can the better like Microsoft best practices to use cross-cutting components in initial and the beginning of this middleware. Then you can use our favorite frameworks. So the middleware components are formed like as a pipeline, as a chain of components, as I told you that, and are executed one by one by informing to other framework that okay, guy, I finished my responsibility. You please take care the control from now onwards. You can execute your things. In the second middleware, in the middleware second part also do the similar thing. The finally the control it gives to the server and it is used to main the main advantage here the security, the request routing, diagnostics, custom middleware of our own design. We can design our own middleware as well. So it is used to pass the components that form a pipeline. So that means we can set up the priority of the components and we can configure in the line of the components between server and application to inspect as well as we can check the routing and modify the request responses messages for particular specific purpose as well. So where exactly we can configure these middleware components? What is the place in the solution? MVC6 solution. So we can configure our request pipeline in the startup class that is used to handle all the requests made to the application. This class is, we can say that the entry point to the application and responsible for setting up the application. It has some configuration settings apart from the middleware. You can set the middleware and these services it will use and how will the request will process. Here we can configure and add the middleware services like MVC, Entity Framework, Identity Services, Logging, Routes, and even we can add it and as well as we can delete these middleware components. And there are built-in supported middleware provided by the Microsoft authentication, cars and diagnostics and routing sessions, static files. Authentication provides authentication support. Cars is a configuring the cross origin resource sharing. Diagnostics it includes support for error paging and runtime information and some insights as well. And routing is it defines we can define our routing over 4 MVC 6 amps. We can session from the session we can maintaining all the user sessions. From the static files it serves all the directory browsing information and the static file information. The third part of third logical layer of Katana is the server. The server is responsible to open the network related sockets and it listens like request what are the incoming requests and how to process and send back those requests through the pipeline of OWIN components specified by the user. Like based on our specification, how we specified the middleware components and request pipeline, it executes as per our configuration only. So there are two server implementation from the Microsoft. One is a system.web, second one is the HTTP listener. The system.web, it as previously mentioned, IIS in the concert with ASP.NET Pipeline acts as a both host and server. Therefore, when we choose this hosting option, IIS both messages the host level concern such as the process activation and also listens all HTTP incoming request, HTTP incoming request. For ASP.NET Web application, it then sends this request to the ASP.NET pipeline. So the Katana like system.web host registered ASP.NET HTTP module and HTTP handler to interact like intercept the request as they flow through the HTTP pipeline and send them through the user specified OWIN pipeline. So that means here it works how we configure the middleware. There is no customization over here. We can, as per our request, as per our configuration, the server executes our pipeline. There is second way of implement the server is HTTP listener. So this Katana server uses the .NET Framework HTTP listener class to open the socket, and it listens from the HTTP request. And this is currently the default server selection for both Katana and self-hosting API and OWIN host.exe. So there are two hostings right now. Microsoft support OWIN host and self-hosting. For these two, this Microsoft HTTP listener is the default server. The fourth and last layer of Katana architecture is the hosting. The host is responsible for managing the underlying process. It also responsible for starting and maintaining the process within which the application runs. So this workflow management, the selection of servers and construction of OWIN pipeline is very easy to developer. So that means we are hosting this application, and this based on this new hosting environment, it gives developers so flexibility even for the server to execute and this correct OWIN pipeline. And there are three hosts supported by the Microsoft. One is the IaaS and ASP.NET. These are favorite host environment. Then we can make our own custom hosting as well. And apart from these two, OWIN host is the third hosting environment. The IaaS and ASP.NET using the standard HTTP module and HTTP handler, and the OWIN pipeline can run on IaaS as part of ASP.NET request flow. This hosting supports and enables us to install the Microsoft ASP.NET host and system.web from the Nugget package into the web application project. And the custom world, the Katana component suits to gives the developer to ability to host application in our own custom process, whether that is the console application or Windows services. It is this custom host is very similar to older like the currently which we are following the self-hosting. So by using this custom hosting, we can develop like we can run our .NET MVC6 application even from any USB supported devices as well. Third one is third is the OWIN host. This is the executable file named OWIN.host.exe. It can be directly run and used as a host for any kind of application. What exactly the request pipeline? How we can configure and how we can set up the request pipeline? If you see this, the request goes something like this. And once we request a particular resource from the web server, from web server it goes to Katana, from Katana to ASP.NET. The ASP.NET 5, this ASP.NET 5 introduced new modular HTTP request pipeline. So that can be hosted on IaaS or any OWIN based server or our own process. Let's see how it internally the request uh, processing happen. So when we request, as I told you, and I shown everything, all four components in the logical diagramming. When we hit the request, it goes to the server, then it goes to all the middleware components from our application. This is the host where we can place our server and middleware and applications. So this is the request pipeline. Like when we request anything from the browser makes a request to the server. The server forwards this request to the host listening to that port. The hosting environment could be on IaaS, on Windows, or self-hosting environment on Linux or Mac OS. The hosting environment starts to execute the application pipeline like the middleware starting from the first middleware. They respond directly and not execute the rest of the pipeline. So we can manipulate our responses in one way or another way. So that could be authentication or add some extra data to the response. So OWIN and Katana project implementations. In nutshell, we can say Katana. What exactly the Katana and OWIN and OWIN and Katana project. This implementation are not really new to the programming model, but rather the abstraction to decouple the application programming model and frameworks from the server and hosting infrastructure. That means the main intention behind this design is they want to make decouple our application and frameworks from the web server and hosting environment. When we build a web API applications and frameworks, we use ASP.NET and web API framework, irrespective of whether or not the application runs on OWIN pipeline using these components from the Katana project. We compose this middleware in the startup code as I told you in the earlier. There is a startup.cs where we have constructor, configure and configuration services. In the config method, we can build our own middleware. In the startup code, like we can register series of there is a use statements. We can register our middleware, generally one for each middleware component that will process for incoming request. The experience, like what things we can give from this experience, will have the same effect as registering our HTTP module in the current system.web world. Typically, the larger frameworks, the middleware such as ASP.NET Web API or Signal or will be registered at the end of the pipeline. This separation of middleware components from each other and from the underlying infrastructure components, it gives like components to evaluate the different velocities while ensuring that the overall system remains stable. So that means that the registering, the way we configure the middleware, it is not completely new. We already doing the similar things when we register a HTTP module, HTTP handlers. The only thing is here is when we added this middleware on the fly also we can update without completely or like rebuilding our application. That means there is a like little decoupling from these components. The main advantage of Katana is using this component-based approach is to decouple the web server and our web application. And this gives us the multiple option to use any component for any of the different layers. This is definitely the context is different from the older previous versions of ASP.NET, System.web and IIS. So in nutshell, we can say that applications are ASP.NET applications, MVC applications. The frameworks are MVC6, Web API, Signal or Identity, servers are System.web and HTTP listeners, hosts are IaaS, self-host, Windows services, or even OWIN host. So again, this is similar. I just given. So if you here see the similar thing I explained by diagrammatically, I'm going to explain you. The host, we can host our IaaS, OWIN host and console. Servers are system.web, web listener or HTTP listener. Middleware MVC or web API or Signal or applications like MVC application, web pages, web API applications. So by concluding this session, like I have explained what exactly the open source and cross-platform, how MVC6 redesigned, ASP.NET 5 is redesigned from the ground level to support for open source cross-platform by using this OWIN architecture. And we also seen that how it is coupled our ASP.NET runtime and web server and what exactly the OWIN and this open web interface for .NET OWIN architecture and OWIN is like is a body of specification what exactly the Katana architecture and how exactly Katana architecture fits in our ASP.NET world and how it is providing interface and how it is decoupling our web server and ASP.NET runtime and we have seen the middleware and how we can compose set of middlewares and how we can configure middleware in the request pipeline, and where we can configure and our middleware in our ASP.NET MVC6 application. So that's all about this Katana OWIN and Katana architecture. And thank you very much. If you really like this video, please subscribe to my YouTube channel. You would get notified further latest updates from this channel. Thank you so much.